Hello, guys. I have to do this again. I'm putting together a video lecture for you. I've been called into jury duty, and there's nothing that I can do to get out of it. So I'm not going to be in class for the next maybe 3 to 4 class days. Okay. Today we're going to do a video lecture. I don't know exactly how we're going to do this in next week, but I want to take a quick minute to tell you that you have to take these recorded lectures seriously. Just because I'm out of school doesn't mean that you don't need to learn this stuff. Okay? The semester exam is coming up. This is all going to be on the semester exam. You will be having a test coming up very soon on Unit 3, and all of this is going to be on that. So I can't stress to you enough how much you need to take this seriously. You can do this. You guys can learn this. You don't you don't need me necessarily to be in the classroom, but you've really got to trust me when I say take this seriously, write down notes, email me whatever questions you have. I'm going to do the very best that I can to teach this to you remotely. Okay? So having said that, let's get into today's lecture. All right? So in class, last week, I showed you a demonstration where we boiled water. Actually, what we did is we took ice and we took that ice and melted it. And then we took that melted water and we boiled it. And during that entire process, we were recording the temperature. Okay? Okay, I just drew a little diagram showing the solid water turning into liquid water and liquid water turning into gas water. In other words, steam. We call solid water ice. We call liquid water usually water. And then we call gas water steam. Okay? So we saw this entire process in that demonstration. And while we were doing this, we were taking temperature readings the entire time. What I'm going to do now is I'm going to show you a graph like I showed you in class when the instrument was taking readings. It automatically created a graph, and I showed you that graph. I'm going to recreate that graph now in a drawing in a second. All right, guys, I'm drawing a graph that we actually saw in class. While I was doing that demonstration, the instrument that we were using, the vernier temperature probe, the vernier LabQuest, recorded the data and generated a graph. And I'm just going to show you, hand-drawn, what that graph looked like, because there's a lot there that we need to talk about. Okay, so first off, let's just really reiterate what happened in that demonstration. We started with ice that was at -4 degrees Celsius. Okay, that's below the freezing point of water. Okay, that's below the freezing point where ice is formed. Okay, less than 0 degrees Celsius, -4 degrees Celsius. As we added heat, now as we're going to go forward in time, we're adding heat. And when we added heat to the ice warmed up. Okay, I want to really emphasize here, and I'm going to call this step 1 right here. Okay, I want to really emphasize something there, because what you would think is happening there is you would say, oh, the ice is melting. No, the ice is not melting at this point. Okay, it's so important that you get that. Okay, it's solid water that is increasing in temperature from from -4 degrees Celsius to 0 degrees Celsius. Okay, no melting has taken place. I just wrote this out so that you write this down in your notes. This is really super important, and this is not intuitive. Again, you would have thought that during this time the ice is melting. It's not, okay? It hasn't started melting yet. All that we've seen is that the added heat went into increasing the temperature of the ice, of the solid ice. Okay, let's move on. Okay, now as I'm talking through this, I'm going to draw on this graph. Once we have the ice, the solid ice at 0 degrees Celsius, now we go from all solid and we start melting. But during this melting phase or melting part of the graph, temperature did not change. Okay? That's another really important thing to note. And I'm going to call this part 2 of this graph. Okay? During part 2, we're seeing that in part 2, we're seeing that the ice is melting. Melting. All right, so I wrote this out right away. So while the ice is melting, the temperature does not change, okay? You can add as much energy as you want. You're not going to change the temperature. You'll make the ice melt faster, but you're not going to change the temperature until all the ice becomes liquid. So when all the solid becomes liquid. All right, so I really want to emphasize something here. Okay, at this point, right here, where my laser pointer is, okay, we've got all ice, all solid. As we're adding energy, we've got solid becoming liquid, solid becoming liquid, solid becoming liquid, and so on until we get to this point and all of the ice has turned to liquid water. Okay, so melting is complete here. All right, now if we're going to add more energy, and we did, now we've got all liquid water and we're adding energy, and the temperature is increasing over time. It's increasing over time. We're adding energy, the temperature is increasing until we get to 100 degrees Celsius. We started at 0 degrees Celsius. Now I want to use my laser pointer again. Here we've got all liquid water at 0 degrees Celsius. Okay? Now we're adding heat, energy, and the temperature of the water is increasing until we get to 100 degrees Celsius. I am going to call this part of my graph part 3, okay? And during part 3, let's just write this out. During part 3, the liquid water changes temperature with added heat, energy. Okay? So now the liquid water is going to go from 0 degrees Celsius to 100 degrees Celsius. What's magical about 100 degrees Celsius? This is the boiling point of water. Okay? All right. All right, so let me just reiterate this while I'm showing this to you with a laser pointer. We started at all liquid water at 0 degrees Celsius. We added heat energy, right? So we're adding heat energy as we go in this direction. And the temperature is increasing as we're adding heat, okay? That is totally expected. You would have totally expected that. The surprising part of what I'm telling you is this part. where we're having a phase change. We're going from all solid to all liquid. And during that time, there is no temperature change during that time as we're adding heat. Okay? Now, once we get to the boiling point, now we've got water boiling, and we're going from all liquid water right here, all liquid water, and as we're adding heat energy, the temperature again does not change, does not change, does not change. Okay? And that is about where we stopped. Okay? I'm going to call that part 4 of our graph. This was the demonstration in class. This was the demonstration that we saw in class, all right? And as we were adding heat energy, you might remember seeing the water boil. The water was boiling once we hit the boiling point. This is the boiling point of water, 100 degrees Celsius. Here we are, all liquid water, and now we start seeing bubbles forming in the water, and it starts to boil vigorously. And we're adding a lot of heat energy. Heat energy is added. The temperature is not changing. The temperature is not changing. The temperature is not changing. Okay? And then the bell rang, and then we were done. But this is what we saw in class. I'm going to tell you right now that this graph is super important for you to know, all right? And it's really important that you run through the things that we saw here that I wrote out, okay? It's important that you read through these steps, okay? But before I think we go to the next slide, I want to write some of this out, okay? So what happened in part 4, liquid water begins to boil. What boiling means is it's going from liquid to gas. Okay? And during this process, as the water boils, we see no temperature change. Okay. It's just like what we saw when we were melting the ice. All the energy went into... All right, so I just finished writing that. You need to write these things down, okay? It's really very important that you write these things down. And I'm going to read through part number 4. We see that there is no temperature change during that part. We are adding a lot of energy here. We're adding a lot of energy to this, but that energy is not causing a temperature increase. We could add energy very fast and it wouldn't change the temperature at all. It would just make the water boil faster, okay? If you have any experience with cooking, you know that there's a difference between like having a fast, hard boil, right? Compared to a simmer, which is just a gentle boil, right? The temperature isn't different from a simmer to a fast boil. The temperature is the same. It's just that you've got water boiling faster. The more heat you add during that time, the faster it boils, but it does not change the temperature. Okay. All right, I think that does it for this lecture. Make sure that you have all of this in your notes. If you need to watch this again, I know it's not the most exciting thing, but I really want you to do well with this, and I'm really sorry that I can't be with you to show you this stuff, but this is the next best thing, all right? So I'm going to have a worksheet that goes with what I just told you, and that will be in on campus. I'll see you soon.